One of the unique things about open compute, as opposed to the way hardware has been built forever, is the fact that we have an open forum for collaboration.
To me, the value you get is you get broader perspectives than your own, right? We all like to think we're pretty smart, but in reality, none of us is as smart as all of us are together.
This is a consumer-based design process. It's about what is best for me as a buyer of technology, not what's best for me as a builder of technology.
You've got what is potentially a lot of competing interests, looking at it from their own perspective. But the truth is they all have one thing in mind, which is building better technology, going faster, being more innovative. They have to do that in a trusted environment. I think the Open Compute Certification Lab is a great place for that.
So what we do in the certification lab is we bring in hardware platforms, compute platforms, and entire open compute solutions, and we put them through the same level of testing that you would expect to see through any major OEM as they go through their certification process.
Before the server gets here, the manufacturers have already tested their components. The motherboard manufacturers have tested the motherboard, the memory manufacturer, the hard drive, the CPU manufacturer. So we're doing a system level, server level certification here.
We know what the concerns with open compute are. They are guaranteed levels of performance, they are security, they are stability of the movement and stability of the platforms.
It's really just a matter of trusting that the hardware is going to work in production. I think they have to make sure in their own mind before they make big bets on a new technology direction or a new platform that it's going to work.
That's why we're so excited about the Open Compute Certification Lab, because it answers those questions. It puts every single system and every single solution through a battery of tests to make sure that every single one of those questions are answered.
When we receive the servers, they come in, shipped to us from around the country. We open a box and basically note everything about the server, the serial numbers, who it's from, where it's from, how it was configured when it was shipped to us. There's a specifications manual. This is an extremely meticulous specification to test to. We look for power draw, CPU tests, data center management interface, disk tests, informational tests, inventory, system log. And this is actually just page 2 of the specifications.
We test these solutions holistically, from the silicon, the processor that sits on that motherboard, all the way out to the application that's running on top of an operating system which is loaded on the server.
After we assemble the processor and the memory here and we button it up and make sure that it meets minimum specifications, we then move it next door where we've got a small server room set up for just initial testing. In there we run a 24-hour life cycle test. We run the remote management tests on it. Once we complete the initial testing in our server room, we move it over to the data center where they've got sufficient power and cooling that we can test this server, run it through its paces completely in cooperation or in coordination with a rack of other servers. We look for what we call form and fit. So does it fit in where it's supposed to go? Also function. So we can now run real-life workloads on it. We have a debug tool that we plug in, and we're actually able to watch the processes as it's booting up and as it's going through various stages of the testing process. It's kind of a behind-the-scenes look at what's happening on the motherboard.
In theory, things should work, but until you bring them together, put them in a rack, run them at production levels, and push a lot of performance workloads against them, you really won't know, and I think that's what the lab is all about.
What we have done with the lab is we've cooperated with a third party who has no skin in this game. They have nothing to gain from the success or failure of AMD or any other company that's contributing specifications to the community.
We're making a major long-term commitment to open compute. We think this is the wave of the future, which is critical for UTSA because we're a growing university, and it's going to provide an incredible opportunity for our students.
The coolest part about this lab here at UTSA is that it represents the best of all of the companies involved.
We can think of this as being the assertion that open compute platforms meet a standard set of criteria, regardless of manufacturer, regardless of commercial interest.
We are looking at where the data center is going to be 5 years from now, not where it is today. And we're trying to ready the market for those inevitable changes that companies are going to have to face if they want to survive in the new economy. We know that when a product or a solution comes out of the Open Compute Certification Lab with a logo, it's going to meet your standards around performance, security, and stability. So you can feel good about the investment you're going to make in this product or solution, and you can feel good about the investment you're going to make in the open compute movement.